So let's understand two concepts, because in our t-SNE we have stochastic neighborhood embedding. So let's understand the last two terms, neighborhood and embedding. What do they mean? Imagine in my d-dimensional space, let's assume this is my d-dimensional space. Okay, let's assume this is my d-dimensional space. Of course, I can't draw any dimensional space that is more than 2, but let's just assume that this is my d-dimensional space. I'll just put points here without writing axes. Okay, suppose if I have, let's say if I have points like this. Okay, suppose if I have points like this, right? Suppose if I have my points like this in my d-dimensional space, in a high dimensional space, or let's also ensure that D is large enough. So let's assume in my high dimensional space, let's assume my data is like this. So if you take our MNIST data set, okay, we have 784 dimensions. And let's assume all our zeros are like this, which are close to each other. Let's say all of our ones are close to each other in the 784 dimensional space, which you can't visualize. Let's just say, okay. So let's try to define what neighborhood of a point is. Okay. So let's assume we are taking this point, right? So the neighborhood of this point is typically those points which are close to it. So this is called the neighborhood of these points. Now, of course, we could have some points which are not in the neighborhood. Suppose I could have some points here, right? I could have some points here. So neighborhood, so this red circle here is called the neighborhood. So if this point is xi, if this central point is xi, this circle represents the neighborhood of xi. So neighborhood of xi is nothing but all the points xj such that, okay, let me write it more elegantly here, since we have not yet come to that notation, such that xi and xj are geometrically close. Okay, what does geometrically close mean? That means if I take the distance between these points, the standard distance, right? Every point here is a vector in 784 dimensional space or in the d-dimensional space, right? So if I take the distance between these points, which I can easily compute, right? If xi is one vector and xj is another vector, I can subtract from both of them and I can just take this. This is my distance square, right? This is my distance squared, right? This is distance between xi and xj squared. So if the distance between 2 points is small, then I can define this as a neighborhood of my point. So neighborhood is nothing but just the same meaning of neighborhood, right? That if these crosses are close to x1. So for example, let's name this, right? So let's just name this. Let's call this central point x1. Let's call this point x2, x3, x4. Let's call this point, let's say x10. Let's call this point x20. Now I can say that the neighborhood of x1 will contain x2, x3 and x4, and it does not contain x10 and x20, because x10 and x20 are very far away. They're very far away from x1. Okay, this is the meaning of neighborhood. This is the definition of neighborhood. Neighborhood is basically points which are close to my x1, okay, or my xi in this case. Okay, now let's understand what does embedding mean. Embedding is a very interesting idea. So imagine if I have a d-dimensional space. Let's just say this whole thing is my d-dimensional space, and of course, what is the objective of my dimensional reduction? I want to get this data to 2D or 3D so that I can visualize. Visualization is one of the objectives, right? Now let's assume I have my data set like this. What does embedding mean? Embedding basically means, let's assume I have my points here. Okay, let's assume I have my points here. Let's say this point is x1, x2, x3, x4, x5, x6, 7, 8, 9, 10. Okay, so what does embedding really mean? Embedding basically means that for every point here, see, I have my x1, x2, x3, x4, x5s here, right? And similarly up to x10. Embedding basically means that for every point here, I create a point in 2D. Okay, so my x1, for x1, I'll create a new point here called x1 dash. Okay, for x2 here, I will create a point called, I could put a point here and call it x2 dash. Okay, for x3, I could create a point here For x3, I could create a point here and call x3 dash. Okay. So embedding basically means that I'm taking points one by one, okay, and placing them, or finding its, for every point here, for every point xi in the high dimensional space, I'm finding a point xi dash in the low dimensional space, right? 2D. So here, let's imagine what is this d-dimensional space. Here your xi has xi1, xi2, so on and so forth, xid, d components. Here in xi dash, what do I have? I have xi dash 1 and xi dash 2, right? So for every point in the high dimensional space, if I find a corresponding point in the low dimensional space, okay, such a thing is called embedding. Okay, so embedding, basically think of it like this, as if you're picking up a point and placing it in a, so you're picking up a point in a high dimensional space and placing it in a low dimensional space. Okay, that's what embedding means. Okay, we'll understand what t-SNE is in more details, but I just wanted to define these two terms of what embedding means and what neighborhood means. Those are the last two, neighborhood, embedding. We'll understand what t distribution and stochastic are little later.